Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zahinuddin. My matrix number is DF220148. So today I will present about the introduction. First, our group choose E14 building, which is located beside the rugby field. So this building have 3 classes and 1 toilet. One classes are fit around 30 to 50 students at one time. So the factor of choosing this site location because the building design. The design is simple for us to analyze and discover more about the mechanical system, which is plumbing system, HVAC system, and fire protection system. Next is easy to access the building. We as group are easy to investigate this location without taking any permission from the above organization. So it is easy for us to discover more about the mechanical system in this building. And lastly, the sustainability attraction, which is this building have a solar panel, so it attract our attention to continue investigate this building, which is E14. So the objective of this project, we are able to analyze and improve the schematic diagram for the mechanical system, which is the plumbing system, HVAC system, and the fire protection system. Next is create the comprehensive documentation in terms of the system design, control algorithm, enabling knowledge transfer and future reference to the similar project. Next is investigate the location, which is the E14 building, to achieve a less consumable energy. And lastly, justify the problem and suggest a solution for the site selection, which is the E14 building.
Hi, my name is Yo Ji Hui, and now I will explain about ventilations and air conditioning system which exists in the block E14. So E14 has 3 classrooms, which each classroom has 1 exhaust fans and also 2 air conditioners. So the air conditioning system consists of 4 main parts, which the first part is the evaporator, which is in the indoor units. It consists of the refrigerants which to absorb the heat, and also consists of the air filter to filter the air contaminant from the outdoors air. So the next one is the refrigerants. Will go to the compression part, which is help to increase the refrigerant pressure and also its temperature. So the next one, the refrigerant will transfers to the condensers, and the condensers is help to release the heat by blowing fan. So lastly, the refrigerants will go to the expansion valve, which is help to reduce the refrigerant pressure and control the amount of the refrigerant to the evaporator. The selected air conditioner is the Axens air conditioning, which is refrigerant has the lowest GWP, has the lowest potentials, global warming potentials. Based on the room size and also the estimated student in one classroom, the total BTU required is 33,000. So means that the current air conditioners, which is the 2.0 HP air conditioner, has meet the classroom cooling capacity requirements, as the calculated requirement just need for the 3.5 HP system. The ventilation system that exists in the block E14 is the exhaust fan, which the toilet and also the classroom has 1 exhaust fan. The exhaust fan helps to remove the unpleasant odor, the stairs, and also the excess moisture, especially in the toilets. So it helps to create a more fresh, more comfortable, and more hygienic environment. It is recommended to run the exhaust fan before starting the air conditioners to remove the super hot air near the ceiling, and it may cause the energy wasted because the cool air inside the classroom may be absorbed out to the outside when the air conditioner is opening. So the next one is the wall-mounted fan should be installed in the classroom to facilitate the distribution of the cool conditioned air.
Plumbing system. A plumbing system is an essential component of any building, providing a network of pipes, fixtures, and fitting designed to convey water and wastewater. Its primary purpose is to ensure the efficient distribution of clean water for various household and industrial activity, as well as the proper disposal of wastewater. Plumbing system has two sections, that is water supply system and drainage system. Water supply system. Water supply system is the system that brings the fresh water to the building. For water supply system, they have two systems that are used to supply the water. First is the direct system. Direct system is transfer water directly from the main water supply to where it's needed without using any intermediate storage tank. That means the water transfer from the main water supply to all units in the building. Second system is the indirect system. Indirect system is the main water come in via a rising main water reservoir tank and directly feeds a storage tank at the high point in the building from where the water is fed to all the other taps using gravity. That means the water transfer from the main water supply to the storage tank, and the storage tank will transfer the water to all the unit in the building. For our study, we observed the information from the building E14 in UTHM. In this building, indirect water supply system method used to distribute wastewater to its various units. As I said before, process of water supply using the indirect system is water supply from the main water tank to the water tank or the storage tank at the top of the building, and the water from the storage tank will be transferred to all units in the toilet. They have two benefits using the indirect system. First, indirect system has a big storage tank that holds a lot of water, which come in handy if there's a problem with the main water supply. It means that the problem from the main water supply did not impact the water supply in the building. The next benefit is the pressure from the tap is not too strong because it's come from the storage tank, and that make less noise and less wear on the taps. Next is the drainage system. A drainage system in a building helps manage water by guiding rainwater and wastewater away. That means the drainage system is the system that throws the wastewater from the building. A good drainage system is important for keeping the building structurally sound and ensuring a dry and safe indoor environment. For our study, the wastewater from all units in the building E14 will be removed to the septic tank. In the area of this building, there also has a sewage pump building that was constructed. A sewage pump, alternatively referred to as injector pump, include a reservoir or basin for gathering sewage from the building. Functionality of the septic tank. Septic tank have three layers. That is, first layer is the scum. Scum is the uppermost layer of waste made up of soil and fats that rise to the water surface when give time. Second layer is the effluent. Effluent layer, remaining water after scum rises and sludge settles. And the last layer is the sludge. Sludge is the solid waste that sink to the tank bottom during the separation from water. Next is the recommendation. The recommendation to improve the plumbing system in the building E14 is providing water efficiency. Water efficiency system involve adapting advanced technology and practices to provide the same or better service while using less water. The example of water efficiency system is installation of rainwater harvesting system. This system collects rainwater and then reuse the water to supply water to the flush tank. The benefit using the water efficiency system is it reduces the reliance on the main water tank, resulting in lower water consumption and cost saving on water bills.
Now we will look at the fire protection system in buildings. It refers to integrated mechanical components designed with the aims of protecting building occupants, mitigate the damages associated with events of fire. They can be mainly categorized as either active or passive. Active fire protection system is crucial to actively detect, control, and suppress fires in buildings through a certain amount of motion. For example, its key components include alarm system, fire suppression systems, and fire detectors. While for passive fire protection system is typically function to limit structural damage. and spread of fire by slowing down mechanisms in different aspects like building utilization, compartmentation, and mean of escape. For active system outside, which is building E14, it is expected that the block of building for both indoor and outdoor space is well equipped with carbon dioxide fire extinguishers, which are class 21st B for fires involving flammable or combustible liquids and gases. These CO2 extinguishers are particularly effective for class B fire as it can significantly displace the oxygen amount and interrupt the combustion process, leaving no residue. In addition, the equipments are certified with BOBA license by Fire Department of Malaysia to ensure its functionality and application from various safety requirements. For fire hydrant pillar is also available by strategically located near the building block to ensure a quick access to water supply. For the fire safety factor, it's also connected to the hose box, ensuring an effective firefighting operations during fire emergencies. However, it is expected that the pillar is provided no information about the water pumping capacity as well as identification markings of water pressure according to color coding scheme. From site visit, it is expected there are a few exhaust fans installed in each lecture room as the mechanical ventilation system to direct smoke out of the building, thus reducing its impacts on both occupants and firefighting operations. By integrating natural and mechanical ventilation operations referred to BS 7346-2003, the building is also equipped with sufficient numbers of lowers and exhaust systems at toilets and electrical rooms to aid fire control. For passive system, it mainly involves the division of whole block E14 building into multiple distinct rooms by reinforced concrete walls to contain the fire within a limited area, thereby minimizing its impact on occupants and structures as a whole. And the building is also separated into several compartments such as storage room and water supply room, along with the integration of fire-resistant furnishings to create a better fire protection strategy. The fire protection system may require retrofittings as shown in the improvement drawings to the existing fire safety system and additional implementations of protective features in the building by considering the use of surveillance, prevention, and evacuation systems. In this study, a proper design and operated fire alarm system is suggested to be installed in this building along with nearest building to provide early notifications to building occupants. Additional modifications can also be made to the building, for example, the increased use of openings for ventilation efficiency in firefighting strategy and reducing the overall operation cost of fire protection system as well. That's all from me. Thank you.
A very good day to Dr. Sushilawati. My name is Chong Ho Yi, metric number is DF220156. Now I will present the drawings of the mechanical system at Block E14. In these drawings, the mechanical systems around Block E14 have been identified, including the ventilation and air conditioning systems, plumbing systems, and fire protection systems. There are 4 interior zones in this building, which are toilet, lecture classroom 1, lecture classroom 2, and lecture classroom 3. Based on these drawings, the components of ventilation and air conditioning are demonstrated clearly. All the related components are drawn in the light blue line. These components include windows, exhaust fans, air conditioning indoor units, and air conditioning outdoor units. For the plumbing system, the white line is used to indicate the sanitary equipment in the building. The green line represents the water outlet. The orange and dark blue lines represent the water inlet and water supply, while the purple line represents the storm water flow. All the water outlet will then flow to the outside pipe, gathering together in the main pipe and being delivered to the manhole. For the fire protection system, all the fire protection equipment is shown in the drawing using the red line. They consist of fire extinguishers, emergency lights, fire hydrants, and fire hose. There are some improvement methods proposed to improve the mechanical system in the building. The improvement methods include installing the wall-mounted fan, adding windows, installing fire control panels, installing manual pull stations, and installing the stormwater collection system. That's all for the part of the drawings.
In conclusion, there are many benefits that we get from our project, which is in terms of human comfort, mechanical system including the HVAC contribute to indoor air quality, optimal temperature regulation and ventilation, enhancing overall occupant well-being and satisfaction. For the energy efficiency, properly designed mechanical systems play a vital role in reducing the energy consumption and the carbon footprint of the building, aligning with global sustainability goals and mitigating the climate change. And then for the environmental impact, the adaptability of the mechanical system supports an environmentally conscious design, fostering resilient and user-friendly structure that positively contribute to both human and well-being and the planet's health. So that's all from our group. Thank you.